Hi everyone, so in this second video tutorial we will be focusing on the mesh, the ability to visualize it, to refine it, and eventually to use some alternative data sources for elevation. So we will be working with that same tiles which we built last time in South Carolina, and I briefly showed you how you could visualize the mesh, and this is what I'm gonna explain now in a little bit more detail. So here is the directory of the tile, this is the mesh file, and to use this software called Emedit, you first need to associate these extensions with that software. So I guess in most OS you will right click on the file and say something like associate with or open with, and then let it be the default software. And the software which you need to associate these mesh files with is contained in this utils directory. This is the Linux version of the software, this is the Windows version, and an OS X version should be added shortly when I will have time to compile it for OS X. Okay, so once this is done, you can simply double click on the mesh file and you will have this wireframe representation of the mesh. Okay, so the shortcuts to visualize this mesh are Z and Shift Z to zoom in or zoom out. You use the arrow keys to move the mesh around when you need to go somewhere before zooming, and you can also use shift arrow keys to do some smaller steps. So this is for navigation. Then you can have different representation of the mesh. If I right click here and go to render mode, here we are seeing the wireframe. I'm usually using the shading mode. Usually also add the material colors, whose shortcut is little e, this way. Okay, and that's about all what you need to know. Now, we said this mesh is a rough one, although you can see there are already a lot of triangles, there are 300,000 of them, but it appears that it has not been refined as much as the elevation dataset could give us. So there is certainly room for improvement. And okay, so now let's quit this one. I open the config window, and the parameters I'm going to explain now are these ones, and in particular the curvature tool. The meaning of this parameter curvature tool is the following. The level of refinement of the mesh locally is somehow proportional to the curvature of the underlying surface as it is given to us by the elevation data. And this curvature tool value somehow defines the proportionality constant between the level of refinement and the curvature. So the higher we are tolerant to curvature, the less triangles there will be in the final mesh. And the smaller curvature tool is, the smaller we are tolerant, and therefore the higher the number of triangles in the final mesh. In version 1.30, this curvature tool value is no longer unique, but can take 3 different values depending on the underlying scenery. There is a special value called apt curve tool, which is used over airports, and coast curve tool, which is used close to the coastlines, because these are typically 2 places where you might want to refine the mesh further. These 2 parameters, airport curve X and coast curve X, define how far from the boundary of airports or from the coastline you'd like to have this further refinement applied. Okay, so that was the default values. You remember what the mesh looked like. Now we are going to refine this. Let's put this to 1 and maybe this to 0.2. Maybe I can increase. No, let's keep it this way. I apply, as every time I change a value in the config window, and now I retriangulate the mesh. So this will be updated in a short while. We have lifted the values of triangles. It is still a low value from 300,000 to 400,000, but maybe now we are going to see a little bit more in the wireframe. You can see immediately, for example, the fact that we have more triangles close to airport. You can spot them. I hope the final video on YouTube won't be too difficult to follow. Maybe if I zoom, you can see there's an airport here, there's another one here, and so on. And if I look at the wireframe, also you see there are more places now where triangles have been refined because of curvature of the underlying surface, of the underlying ground. And if I go to render mode shading, well, it's not very apparent yet here at this level. Let's have a look at Columbia Airport. We will see when refining further and further. So you should keep in mind that representation of the airport. We can see there is kind of a plateau here on which the airport is lying. And this is our present representation, which is already much finer than what it was initially. You see the triangles here are smaller in the airport region than away from it. And that's because of the definition of the curvature tool close to airport. Maybe we can go a little bit further and try to push even more nodes. So let's put, I don't know, the 0.5 here and 0.1. Apply, triangulate. Let's do even a little bit more. Apply, triangulate. My goal is to see the possible improvements close to the airport. So we are starting to reach the level where the number of triangles will be the maximum possible, where our elevation data is still useful. Afterwards it would just be oversampling. The shading should already look better. And if I zoom into the airport, now I should see the plateau a little bit more. Yes. So here we are probably to the level where we have exploited the elevation data at its best here for the airport, and that should already be not too bad, or actually already good, I would say, testing in Explain. Okay, but that was using the default dataset, which has a step size in latitude and longitude of roughly 90 meters. In the config window, you have this line here that allows you to define other elevation datasets, and there are a few ones available by default, and we'll be using here, for example, this one. So a 1 arc second of resolution, which is 3 times more resolution with respect to the default viewfinder panorama, so 3 times more both in latitude and longitude, so that would have something 9 times more pixels with respect to the first one. So let's do that. Let's do this, and maybe I will go back to more reasonable values here. Let's apply it, and now I can triangulate. Oops. Oh yeah. So there is this since I changed the elevation data, and the elevation data is used already at step 1, I need first to redo step 1. Maybe I'll cut that part in the video. Okay, so now we are back. Step 1 is finished. We can redo the triangulation with our new elevation data set. And let's see the final number of triangles, which you see is lower than the last one we did with the rough data set, because we have used higher values of curvature tool, but we will be comparing both. And that's not because the mesh has less triangle that it is less refined, because maybe the triangles are placed in better locations and with better values. Let's go to Columbia. Okay, so the first, before the airport, the first thing you can see is that these are probably some queries, and they were not there, at least I don't remember seeing them as defined in the viewfinder panorama dataset. So here you see from scratch the benefit of having a higher resolution dataset. And what about our airport? It's less, it looks less on a plateau than it was with viewfinder panorama. It could actually be that the viewfinder panorama raster got some treatment on the airport, making it rather flat and plateau-like, whereas it could be that this, you see, it looks like the road is going into in between two little hills, like here. Maybe we will refine a little bit further close to the airport to see what's in this raster. And after that we will be using still another dataset, even more refined, but which will be local, not covering the whole tile. I will show you where to download it, but first let's see the airport. A higher result. Here it's clear that we have put more budget here on the airport. And now it starts to look really more, if you compare it, look back in the video and compare it to what it was in the viewfinder panorama website. Here you can see that we really start to get some details which was not present in the 3 arc-second dataset. Okay, let's go still a bit further. And now we'll be using a third dataset, but that one will be local. So first I show you where to download it. This is the national map viewer, so for the US. And here on top you have elevation products. And we will be, so this is the dataset which is used, for example, in Fort Boy's US tiles. This is already 3 times more resolved than the one we've just used now. It's globally available for the US, but we will be using this, try to use even that one. So that one would have a step size which is something like 3 meters, so 1 point every 3 meters in latitude and longitude. And so it's not globally available, but it happens to be available for Columbia Airport. Where is that? Here. Columbia. So let me zoom to it. I lost the airport. There it is. Okay. So here I'm at Columbia Airport. So now I usually zoom into so that I have less products to choose from, and this is the one I want. So I will download it. Notice the year in which it was made, so this is probably LIDAR data from 2010. Sometimes it's outdated if there were some construction works. I hope it's not the case for Columbia. Let me download it. It's done. Extract. Okay, there is a bunch of files inside, but the one which is the largest in size is the one we're interested in. So I'll extract it. Okay, we're done, and I can trash the archive now. Okay, so that's the data set, but it doesn't span all the tiles, so I will use it in combination with this one. So instead of changing the data set, I will add one, and to add another one, I shift-click on this folder to choose it, and I go back to my download directory, this one, and I select it. Now I have 2 datasets. I apply it, and I need to redo step 1 with this one, and so again I'll cut the video and be back when it's done. Okay, so we are finished, And now we will do the triangulation. So it's going to be a two-step triangulation, because we will do a first triangulation with the first dataset and a refinement of that triangulation with the second dataset. And that's the aim of this field iterate here. To use this ability to have many datasets, here we have two, but we could have as many as we wish. We need to put the cleaning level here. Maybe you have seen when we were doing mesh, some files were created and then erased when the mesh was done. We need to keep them, and so I put the cleaning level to 0 and I apply. Maybe I will put back the airport curve tool to this value here, because that one was maybe extreme. And okay, we do our first triangulation, so the iterate 0. Triangulate. At this level, the refinement is made only using the 1 arcsecond NED dataset. And we have our 800,000 triangles. Now I want to refine the mesh using the second dataset wherever it is available. So I put iterate to 1. These high-resolution datasets, they don't cover the whole tile, they don't cover also the whole rectangle on which they are defined. Often they have holes. Maybe you have seen that on the national map viewer. So for this one, I choose fill no data to false. I don't want to try to fill holes of data. I do apply curvature tool. Okay, so the data set which I have downloaded here has a larger extent than the airport. So if I keep the parameter as they are here, my mesh will be much more refined in all these, the extent of that data sets. This is maybe not what I want. I just want to put some budget where the airport is. So for this second iteration, I will put a large curve tool, maybe 5, for everything which is not close to the airport, and let's put maybe, I don't know, 0.5 for the airport, but here we have a strong data set. I do apply, and now I triangulate again. So the existing mesh is first read and then refined, and we end up with actually not that many triangles. Maybe let's try to, well, not that many. We have increased by 80,000 triangles just for the airport, which is not nothing, but not extreme as well. I have worked with cases where for a single airport I could add 500,000 or even close to 1 million, but maybe yes, let's put 0.3 here, and let's increase also a little bit the extent around the airport, which we want to make very precise. I do apply. I don't change the iterate. I want to redo this iterate 1. If I wasn't pleased with the 0th one, I would go back to iterate 0, etc. Okay, so now we have our 200,000 additional triangles, and we can visualize our new mesh. Where is it? Because now I have plenty of files. There it is. Okay, so you can see, so that was probably the extent of the new dataset. I zoom in, and I see that inside this zone, this square here, the airports are much more refined. There is not just the Columbia airport, but these 3 other ones, which I don't know. And let's zoom in. And let's shade it. Put the colors. And now you see the resolution is much higher than it was. You can see here, you can see the roads, which at 3 meters resolution can be seen in the dataset. When we had the dataset for which each pixel was 90 meters, there's no way you can see a road in the dataset. We see that there is probably, I don't know what is this, but there are, you see close to the taxiway here, there are probably places of lower resolution, but you will try this mesh directly in Explain and you will see what these things are. And okay, so this is it. You can, so we have done this for airport here, but we could use a higher resolution data sets in different places, in places of interest. They do not need to be to be airports. Okay, so this is the simplest example of using a high resolution dataset in addition to the default ones. Maybe the last remark is that I have used this dataset as is, just after downloading it, and the reason is that it is already in a suitable format, in the suitable coordinates, in the geographical coordinates, or close to. In different cases, maybe I will make separate videos explaining GDAL. In different cases, you would have data sets that maybe has many small files in different coordinates, and you'll first need to put them in the appropriate format, but usually that's just a one-line command. Okay, I think that's all what I wanted to show you. You can already experiment now. You see the data was available in many places in the US. It's available in many different countries, sometime in resolution that with LiDAR data is becoming very high in many places. Thanks for watching.